Hello, welcome everyone to, I believe, the 5th Gitly training session by now. Today we're going to look at some things that happen during Git merge. And the perspective we're looking from is from a Gitly engineer, so someone who knows the Gitly project but wants to understand how it fits into the larger picture of GitLab. I think this is also interesting if you're looking at this stuff from a different angle, but this is the angle I'm going to approach it from. So merge requests. Let's make a merge request, and then I can point out the things that I want to look at. This is my GTK. I hope we can see this. And I have the GitLab test project here, and I'm going to fork this because things get more interesting when we work across forks. So we just want to start out in that scenario.
Side note, is that using the duplication stuff already?
Maybe. I don't remember if I have the feature flag turned on. The nice thing about the way we implemented deduplication is that it doesn't really matter for anything I'm saying now. Yeah, well, maybe that's a topic for another time. It shouldn't change what happens now. Well, in the future, the forks will be faster, so that would change what happens now, so we're not looking at a spinner. Okay, there we are. So I'm going to create a merge request and then point out some things, and that will lead me to the topic. So first, let's create a merge request. I'm now in my fork. So my fork is in this group 3. If I change the URL to gitlab.org, then I should go back to the parents. Except that I get punished for not using the back button. Okay, the back button is also slow. Well, development mode. Okay, here we are. So group 3 is the fork. GitLab.org is the original project that we forked from. I'm going to edit a file. Let's say I want to edit the changelog. Maybe that's also a bad idea if the changelog is long. It's probably not. Well, it's not long because I guess I go for this file more often if I want to edit something. The original content of the changelog was not misspelled, whatever. Let's fix the spelling. And let's put that on new branch. Oh, it will be interesting if deduplication does not play a role for what I want to say now. No, what's that? Why did we have a crash? We have a crash because symbol not found. And that is the re2 gem. Okay, well, what do? You do bundle pristine re2.
This is a GDK issue?
Yeah, or a homebrew issue. Homebrew randomly very eagerly upgrades libraries, and C extensions then break. And so I guess this is a little demonstration of troubleshooting. You need to find out where the problem is. And here I see that the gem is called re2, and something like symbol not found to me sounds very C extension-y. And then the fix is to run bundle pristine and that gem in the directory of the GitLab CE code base. And that will reinstall it. And now I have no idea how GitLab is going to recover. Will I have a merge request, or will that whole thing just have gotten lost? So I want to show, let me tell you already what I want to show. I want to show that this edit I just did created a commit in the fork, but that commit does not exist in the parent. So actually, it's good that I didn't create the merge request straight away, because that would have robbed me of the opportunity to show that the commit doesn't automatically go to the parent. And so that is the one thing I want to show. You have a commit in one project, and how when it gets merged, it eventually has to end up in the parent project. So how does it get there? And the other thing I want to look at is the fact that the merge commit has my name on it, me, the user, and how did that happen? Where did that come from? Those are the two topics I want to look at. And I'm still going to demonstrate it because I think it's good to see this with your own eyes. Are there any questions about this this idea so far?
Why would creating the merge request rob you of the idea of showing that the commit is not in the parent project?
Good question. That is because once you have a merge request, then everything on that branch that you're trying to merge and that gets added to it over time will automatically get fetched into the target projects. So let's see if this already happened. Probably not. Let's open a new tab with the repository. And then I need to go to my branch, which was this branch, MR1. Come on. So that's the commit I just made. And let's see if that commit exists in the parent project already. So here we have a commit URL, and we're in group -3. I'm just going to change that group name, and I get a 404. So thanks for the question. And so this was the first point I wanted to make. We get a 404, but I'm going to create this merge request, my first merge request. Well, it's not, yeah. Test one. And now stuff happens.
I think you might have created it to the
wrong project.
Yeah.
I wonder what the default is, or how am I supposed to make one across? You're right, it's the wrong project. How do I create one across branches, projects?
If you want to do it like magically like this, then you shouldn't have changed the branch name, I think. Then it would automatically target, I think. I don't remember.
Or maybe, if I go here, does it see that I pushed to my fork?
Yeah, and then create the merge request from there. Clever.
I don't know if it does that. Maybe I lost that opportunity by creating the other merge request. Let's try again. Well, let me just create it here. Let's see, it should be possible. New merge requests. I'm not sure if I can do it here. Maybe I need to be on the other project.
No, you can do it from here. You can select,
thanks. So I look for group -3. And my source branch would be MR-1. Okay, it doesn't like that.
I think you're signed in as root probably, so you just did something on the other project, and in this drop-down thingy, we only show things that you are actively a member of, if I remember correctly.
But I created that other fork myself, so I should be the owner of it.
Isn't the group?
Oh, it's a group.
Yeah.
Let's see if I can do it. Let's see if I can do it from this side.
That should work.
Yes, magic all at once. So this should work. Let's stick with those immortal words. Submit merge request. And yes, we're on GitLab.org now. So here's the merge request. Now remember, this is the window where I had the 404 on the commit. I'm refreshing it now. And I expect this to load because the commit now exists in the repository. So this is magic thing number one. The commit only existed in one repository, and now it's appeared in this one, even though we haven't merged yet. Now, the second thing is that when I merge, let's just merge that. If I go to the activity, maybe I should do these demos on a omnibus instance, because that would be much faster, except that making live changes is a bit harder. So here it says I just pushed to the master branch, but I didn't. So how did that end up there? And we saw in previous videos that these notifications, these events come from the Git hooks. So it's like a push happened, except I didn't do a push. That's the second thing I want to look at. So now that I got that demo out of the way, it only took me 15 minutes. So the topic is merge requests. And subtopics are one, how does data, Git data from a fork end up in the target project of the merge request? And two, how does the merge commit get created? And how much is this like a real Git push? I guess I just said what the order is going to be that we're going to look at this. So how does the fork end up in the target project? What happens there is that the moment I created the merge requests, we kicked off an async job somewhere that tries to call a gitaly RPC called FetchSourceBranch. Let's see if we can find that. And then without a typo. So this is the actual gitaly RPC that makes that happen. It fetches on from a source repository and a source branch onto a target ref in the current repository. So the current repository would be GitLab.org GitLab test. And this one would be group 3 GitLab test. And this one would have been MR1. And I'm not entirely sure what this was. Maybe this was refs heads master, or no, it's not master. That would have been a merge. I think it goes into a temporary, a special temporary ref on the repo. Let's see if we can pull that up for a moment. And let's remote. I think it's public, so I can just type this. 3000 GitLab.org GitLab test.git. And I want to see merge requests. Okay, grep. Yeah, so that got pushed onto one of the merge requests, and I expect it to be one of these. Let's see what our commit ID was. That was something C594. There we go. So this would have been merge requests 9 head. So this is what happens behind the scene, and something called this. do we want to trace back what called this, or do we want to look at what this RPC does?
I think just what it does.
Okay. So yeah, how does this work? Because that's kind of unexpected if you've never seen this stuff before. Let's see, this is a FetchSourceBranch request. This goes into gitaly client.call. Yeah, let's just look at the Gitaly code next. We'll have to come back to this later because there are some interesting things here. FetchSourceBranch. So that would be what I do. So I know that these things. Okay, so this tells me what the name of the RPC is in underscore case, or whatever to call that. And I know that the RPC name in the Go code is camel, not camel case, it's just uppercased. So I would look for fetch source branch without the underscores. This is a mental translation you have to do all the time if you want to look on the Gitly side and then jump over to the Rails side or back, because the calling convention is different. And so GG is my git grep shortcut. And I was restricted to the internal directory because if you do a git grep on the full repo, you get the vendor directory, and the vendor directory is full of boilerplate code that makes no sense. Now with this, I get a targeted result. All this is test code, so we can ignore that. And this is the actual definition. And it's suspiciously short, and that's because this is just forwarding the request to gitaly-ruby. Have I talked about gitaly-ruby in these videos before? So gitaly-ruby is a sidecar of the main Gitaly process, which is just another gRPC service that implements the server side of the Gitaly protocol, but it only implements a subset that for legacy or other reasons is in Ruby instead of in Go. All this does is it propagates the request to Ruby and it copies the response back. So this is a empty implementation. So now I need to use this underscore thing again to find the Ruby implementation. And I do another trick. I search in the Ruby subdirectory because that again targets it a bit. And then we find the gRPC server, the handler for this RPC on the Ruby side. So what are we doing here? We have a request object and we're unpacking it here. We're getting out the source repository. And interestingly, we're doing something with the call here. And we're getting the repository that we're operating on. So that's the repository we're fetching data into. And then we call this method further down in gitaly-ruby, which returns some sort of result. So let's look what that method is doing. And I'm going to just use my search result here. And there's a fetch source branch bang here. So that's probably what we're doing. Oh, and we get more indirection. Is that really the right method? I thought let's look again. Yeah, source repository, source branch, ref. Okay. Yes, that's the one, local ref. Okay, that goes into another method, which amusingly might actually, I think it actually uses, I'm not sure if this still uses rugged. So the fact that this is called rugged underscore fetch source branch is just a leftover of the migration project. This uses something called with repo branch commit, and then that yields a commit, or it does not yield a commit. So why is there an if here? Well, there's this source branch, and this might be an invalid branch, like the branch might have just gotten deleted, it might not exist at all. If that's the case, then we get a nil object here, and we end up in this else branch. But if the commit was found, then this thing is updating the local ref to the commit ID. So that seems straightforward enough. So the local ref was this thing. So refs merge requests 9 head, and that got updated to the commit ID that this branch points to in the source repository. So another question is, what does this thing do? Are you still with me so far? Yeah, okay. So with repo branch commit, I'm just going to use the search function of my editor. And that takes start repository and start branch name. And this instantiates a remote repository, if necessary, unless it already is a remote repository. It does a check. If the start repository is the same repository, then it does a commit lookup in the same repository. So you can actually call FetchSourceBranch on a branch that was already in the repo. And otherwise, we look up the commit ID on that other repository, and we yield that. So where do we get the that commit from? So we need to look at what this remote repository thing is. Let's look for that in the Ruby directory. And let's see. I think I remember that this is, this is the remote repository class. And so what we're actually dealing with is a class that gets subclassed because we're actually dealing with this subclass. So you can see this one is the subclass. Gitaly remote repository is a subclass of remote repository. But to understand what's going on, you actually need to look at both files because they interact with each other. This is maybe not necessary anymore. This is again some technical debt from the migration project, because during the migration project we were not always interacting with this one, and we had an alternative implementation of this one. Actually, this is the alternative implementation. So yeah, you have to read both of them. So what this thing is doing is it's actually making Gitaly requests. Here you can see that we instantiate stubs. So this does the check if a branch exists. This looks in the commit service to see if we can look up a commit. Actually, so that's the find commit RPC. And then so that is preparatory work. And then the final transfer of Git data. Okay, now we need to go back to repository RB. So 1, I should have prepared this better. 2, this is so complicated that me explaining it to you is justified. Let's go back to with repo branch commit. So this guy gets the commit ID, and then okay, it yields. So we have a start commit ID. Right, so this is even more complex. So remember, this thing was the meat of the body that actually fetches the branch. So what are the cases here? So there is the case start repository. So there's the source repository is target repository. That's what we handle there. So here we know that source repository is different from the target repository, but it can still happen here that commit ID of branch in source repository already exists in target repository. And in that case, we don't do a git data transfer because all we needed to know was the commit ID of the other guy's branch. But if we reach this else, then commit ID of source branch is foreign to the target repository. So we need to fetch. This is where the final fetch happens. And that goes into another method that is with repo something something. So that's right down here. So here we can see the magic happening. The real magic is this fetch ref call. And that makes sure that we get the commit inside on something under refs TMP. and that ref then gets deleted. So what does that look like? Okay, let's just follow the path a bit. No, let me start and writing down what the hell is going on here, because it's easy to lose track. So something in GitLab CE wants to fetch group 3 GitLab tests. So that branch MR1 of into GitLab org GitLab tests. That something calls fetch source branch with arguments. The repo in so the target is GitLab org GitLab tests. Source repo is that. That's the wrong way around. This is the target repo. Source repo is group 3 GitLab tests. Source branch is MR1, and the target ref is refs merge requests heads. Wait, 9 head. It was something like that. So we've seen that part. Then fetch source branch is implemented in gitaly-ruby. So now we're looking at what goes on in gitaly-ruby. Gitaly-ruby uses GitLab Git repository fetch source branch, and then that method source branch looks up commit ID, does some work to avoid Git data transfer, because if we already have the commit ID, then we don't need to do a data transfer. If transfer is needed, ends up in this guy with repo tmp commit. And then what does that one do? Yeah, go ahead.
No, I was going to, so this head commit that we actually want to create, that's, why do we need that?
This one.
Yeah, that one.
We need that because ultimately the goal is that somebody clicks the merge button and we get a merge commit. And merge commit is just a normal Git commit. It can only reference.
But why do we need it when we create the merge request already?
That early already, you mean? I'm not sure. I think it's maybe so we can generate the diffs faster, or no, I don't have a good answer. I think you're on the create team, Bob, so maybe you you would know. I don't know if it always worked like that, but in the current design, we fetch it eagerly. It might also be because I think we try to keep some sort of records of, I think if the fork completely goes away, we want to keep the commits in the state as they were before they got merged.
I think this is because I think that this thing is actually quite recent, because I thought that we didn't do that until we merged the merge request.
I think, yeah, I'm
Doesn't
not sure.
matter.
I think at the time of the Gitaly migration project, when we were dealing with these RPCs, it was already the case that fetch source branch was called independently of creating the actual merge commit. So I don't know the exact timing, but the idea that the fetching is separate from creating the merge commit is has been that way for at least 2 years now, I guess. Or yeah, 1 or 1.5 years or more. Okay, thanks for the question. So we're trying to figure out where this data transfer happens. So then we're in this repository with repo tmp commit, And this thing will fetch onto refs tmp some temp ref, yield commit to caller, delete the temporary reference. And so the caller of this thing then decides to create a reference that points to the commit, and that way we remember where the commit is. But we have the freedom to back out and forget that this commit existed, and then it will eventually get garbage collected. Now, how does the fetch happen? So the fetch is actually a git fetch that fetches from what looks like an SSH URL, but uses a custom gitaly transport to fetch from another gitaly server. So this is the part I wanted to get to. So when the data transfer happens, because essentially the fetch is git fetch, so that would be, that is a fake URL. And then it fetches a ref from the remote side, so that would be refs heads mr1. If we want to fetch that onto this, I'm not super sure this is correct git fetch syntax, but this is the general idea of what we're doing. So how does that git fetch from Gitaly internal work? So that uses a custom SSH transport, which is really using the SSH upload back RPC. So from the point of view, how should I? Okay, git SSH is, from the point of view of Git, it starts a remote as command on the server, and then it talks to that command. But if you look at the way the client works, it just talks to pipes on a subprocess. There's a standard in and a standard out where it's sending data, and the intended use is that that goes into an SSH client, and then that goes across an SSH transport to a server, then into Git upload back. But Git doesn't actually know or care if you're really running SSH. And there is an override mechanism in Git called git SSH commands. And if you set that on your Git, if you set that environment variable before you run git clone or git fetch, then instead of trying to connect to the other end with SSH, Git will just run that command and assume that it establishes a session for you. And that is how we got this working. So we're using a normal git fetch command, and we're using native Git to do this fetch, but the underlying transport is actually a native Gitaly RPC. So what happens at this point is, so we use this, let me just finish my note here, use to spawn custom SSH transport, and then fetch data from the Gitaly server that hosts the source repository. And that opens up another can of worms, because how do we know where that Gitaly server is? How does this gitaly-ruby process know where some other Gitaly server is on the network? It knows this because all the way at the start, up here, we send along metadata with the network address and authentication token of the Gitaly server that hosts the source repository. That metadata is handed all the way down, so that when we're down here in gitaly-ruby, we can actually make RPC calls to some other Gitaly server and look at the source repository. And actually, we already used this metadata in here when we did the lookup of the commit ID and doing some work to avoid the Git transfer, because before we do that, we check, does the other repository even exist? Is it empty? what is the commit ID? Do I have the commit ID? Then I don't need to fetch it. All that stuff makes network calls. So we're actually looking at two Gitaly clients here. Gitaly-ruby itself is a client, and that is the code I was showing you earlier. That was the Gitaly remote repository class. Where did I throw that? That is this one. So this class, Gitaly remote repository, is a gRPC client that is making calls to somewhere else. And for the final actual Git data transfer, we're not using, we're using a separate executable that acts as a gRPC client. So somewhere down here, we have the requests. Let's see, where does this data come from? Where does the token come from? It's funny that we have a typo here, but at least we're consistent. That comes from, no, it doesn't come from there. So we have the storage name here. Where do we get the network address from? Address, Gitaly client.address. Okay, this thing creates a client from the call object. Why can't I need to not use a space there. And then this is a new class. Of course it is. So this thing is decoding the metadata of the where the other Gitaly server is. Okay, I'm not sure if I need to be showing you this because this part works. It's there. The important thing to remember is that this happens. And it might be nice if we, let's see, can we log? Okay, I do want to look at this because I want to log for you what this looks like. What is the nicest way to do that? I think the nicest way to do that is on the client. Let's go back to the client. That would be here. Fetch source branch. That goes into gitaly client.call. Gitaly, yes, this one. Okay, so that's metadata. Let's see, metadata merge. Let's log the metadata here. Metadata.inspect. Let's see if that works. So I was saying this transfer happens every time I create a new commit. Oh, and to make it easier to see, let's put some new lines around it. I expect this will show up on the left now. And let's trigger another transfer. So for that, I need to go back to my branch on the group 3 project. Well, at this rate, I think we're going to spend the entire session just talking about this transport stuff and not even about creating the merge commit. So the logging is working. You can see a Gitaly call happening. Let's look for a moment what this is. So here you can see that we use authentication. So this is not an inter-Gitaly call yet. This is just a normal call, but the authorization gets passed here in the metadata and some stuff where we identify ourselves as the Rails app. We get a correlation ID. Okay, let's go to this branch. And I want to look at the files. what I'm going to do is I'm going to create a new commit on this branch. And because this branch is attached to a merge request, I expect that to get fetched into the merge request automatically, at which point we'll see the metadata that flies around to enable that. So let's just edit the change log again. This doesn't really sound passive aggressive enough. Let's put some exclamation marks on there. Let's see what happens now. So every gitly call is now dumping this in the log, which is maybe a bit much. Let's see if I can find, I hope we can find the one. Yes, I just saw something. I think I saw something where the thing was bigger. Yes, here we go. So this is where we're doing fetch source branch. And let's look at the metadata. So we have the normal authentication token, some stuff about the client name. This is what we care about. Let's split out the rest. So, looks like this is base 64 encoded. Well, doesn't look, I'm guessing this is base 64. It's not like I look at this and I say, yes, this is base 64, but I would have used base 64. Let's see. Oh, I can do this the fancy way. I can say base 64 decode. Why doesn't that work? Okay, that doesn't work. Let's just copy this. Try that again. Yes, there we go. It was base 64. Now let's look in here. This is a hash. And what does it say? There's something called default, and it has this address. And apparently, it does not have a token. That's interesting. And what is this thing? I'm not sure why we're sending that thing, and this is not sending a token. But I hope this is not a security bug. I'm pretty sure it's not, but this is, yeah. And let's copy this back here and just overwrite this because it's clearer. So in the case of the FetchSourceBranch RPC, we're sending along this extra metadata back to the Gitly server. The Gitly server passes it along to gitaly-ruby, and then gitaly-ruby unpacks it, and gitaly-ruby uses this data to make gRPC calls to the Gitly server that hosts the source repository. So yeah, I guess at the rate we're going, this is the topic of today's meeting, and this is the thing I want to explain, is that this carrying around of this metadata is happening like this. Any questions so far?
Is the do you think the token's not there because this is using a domain socket and so it's on the same machine? Is there like a different security scheme?
Let's see why the token is not there. Good question. So let me open a new window. The config file in GDK that's used by Gitaly is at the top level of GDK. There is a Gitaly directory, and there's a config toml. So let's see what the settings are over here. This looks like it's commented out. And if I look for the word token, so the answer is there is no token. So this null here is correct. And what is a little odd is that here we're setting a bearer token anyway. Because what is that bearer token now? I guess to answer that question, we should look at how that bearer token gets generated. So that's based on this. And what do we do here? Token storage 2s. So I wonder if this is maybe the empty string. Because if we take the empty string here and we feed that into an HMAC, then you probably still get something. I think that is the answer to our riddle. I think this is returning a null, and if we would have a null check here, we could return early and just say there is no token, but instead it's acting as if the token is the empty string. And this gets ignored by the server because we just looked at the server config file, and there we're not expecting a token.
Cool. I had one more question about this custom SSH transport. So that's not really SSH at all. It's just a transport, right? Because it's using gRPC as a tunnel.
Yeah, yeah. That's a very good question. I think that is the last thing we should look at today. So that thing, let's see, I'm not going to save this file. That is one of the, so one of the reasons I really want to show this is that you see there are two Gitaly clients in action here that you might not know even exist because they are hidden inside Gitaly itself. And like I said, the one is gitaly-ruby, which is a client that will make calls to any other Gitaly server in your GitLab. And the other is called gitaly-ssh. So let's go back to a Gitaly window. And let's look under CMD. So there we have gitaly-ssh. Now this is the other client. And this thing gets, it takes its information from environment variables. Let's see if we can illustrate what's going on here by intentionally leaking some data. So I think this gitaly underscore stuff is data that we're using, and argv is interesting. So what's a good way to log this? Just going to cheat. Pardon. I don't care about the error. Open file. How open file works. I have to cheat here. Name.
It's a mode.
Yeah, and then I want to write flag, so that will be os.oappend. And I'm not sure if I need.
You might need create.
Yeah, or I can just cheat and do this. Then I don't. So I think that will work. We'll know in a moment. And defer f.close. And what do I want to log? First of all, I want to log args. Let's put a new line there. And then I want to see the environment. And wait, I want to do it like this. I'm going to spawn a shell command. How many typos does one need? That's my command. I say env commands dot standard out equals f. And then I'm going to run that thing. So I think this will let us capture some data. And maybe just to be nice, let's put a marker here. Yeah, and let's put a new line on there, because I wouldn't be surprised if this thing does not have a, no, it probably does have a trailing new line. Okay, improvised logging, I think this will work. Now we need to recompile this executable. Let's see, I would do go path equals current directory. This is some weird shell syntax because I'm using the plan 9 shell. The go path is gitly, and I want to do go install of this thing. Cannot use OS append, type int as type OS file mode. That's interesting.
The arguments swapped.
Like this?
Maybe.
Yeah, let's see. It's compiling, and let's check the timestamp on the file. That looks like it just got created. Cool. So if this works, if I got all of this right, improvising on the spot, then next time I edit this file, it will trigger another fetch because the branch is attached to a merge request, and we'll see some data in that log file. Let's see. Drum roll. It took a while before. No. I'm not sure if something is happening here. What did something go wrong in the merge request? It's still not there. Am I looking at the wrong project now? I'm doing something wrong here. It's the merge request on this project instead. That doesn't make sense. Oh, I clicked merge. I was doing a demonstration and then I clicked merge. So I need to create a new merge request. And we learned the other day, I need to do it. Sorry, the other day, we learned an hour ago, I need to do it here. So let's go again. And we want to take MR1. Why am I not seeing? Oh, it's running. Okay. Take 2. Submit. Please log something.
So do you need to create a new commit since you merged it in and they're the same commits now?
I'm not sure if this has been fetched into the other repo yet.
If it was merged before, it was, wasn't it? Or you mean the second?
But I created new commits on that
Yeah.
branch. So those new commits don't exist in the, see, it's still doing stuff. No, that got created. Why? Why is there no data transfer? Maybe my...
Are you using that Gitaly that you just built?
Yeah, good question. I think I just replaced the gitaly-ssh executable that gitaly runs. But let's... Because that's the go install, that's the... This should have installed the executable into the right path. But if it was getting run, then stuff should be in there now.
Because for me, it's always hard to know which thing that GDK is using. So I just
Yeah.
symlink them to like Opal.
Can you do a search for another version of the Gitaly SSH binary to see if it was in a different location?
I'm pretty sure there are other versions, but let's see. I think it uses the. I think we find the executable via the path, via the search path. No, this bin there. And that's the one where I just got the new executable. Why doesn't that work? That just got recompiled. So it should be using that executable. Well, we're running out of time, so I'll have to show this later. Is there something I want to show about this while we're here? Yeah, so this is a separate executable. It's in the Gitaly repo at least. And you may have seen that at the top level of the Gitaly repo, there is this subdirectory called client. And that is a gRPC client specifically made for connecting to Gitaly. So the Gitaly SSH executable is reusing that Go client. And it's actually reusing a lot of how GitLab-shell works. So because in GitLab-shell we're doing, okay, let's end with that. So if you think back to SSH, Git SSH, so what you have there, you have Git client connects with SSH to server, remotely runs git upload back, and it communicates over standard in and standard out. So in the GitLab case, SSH server runs gitlab-shell, gitlab-shell remotely runs git upload back via gitaly, and gitlab-shell is copying the data back and forth that comes in over on the SSH session. So it's almost as if we're using the server-side component. We're skipping a couple steps of what happens in GitLab-shell. In GitLab-shell, you have SSHD, you have the GitLab-shell part, and then that is acting as a Gitaly client and copying data back and forth. And we just directly spawn the server-side part of the Git SSH, the way Git SSH is implemented in GitLab. We spawn that directly and we plug that into Git fetch. And because Git fetch is, in this case, running on a Gitaly server, it has network access to the other Gitaly servers, and we can get away with this. Yeah, okay, this was fun. Well, it was fun. I find this fun.
Wait, what does GitLab-shell exactly do if we run the Gitaly, no, the whatever wrapper we have that executes directly as an SSH command?
We don't use GitLab-shell for that. So we have in Gitaly we have library codes that can do the okay, I need to explain this better. So you have GitLab-shell that speaks gRPC
to Gitaly.
Yes, Gitaly, and that spawns git upload back. And in front of that, you have SSHD, and that uses pipes. And then in front of that, you have the SSH client, which uses internet. And then in front of that, you have git fetch. So that is roughly the chain. And what we do with the internal traffic case is that we have git fetch, and that's
and you replace the SSH client, SSHD, and GitLab-shell part?
Yes, we replace this part and we go directly to this gRPC point.
Gotcha, thanks.
Which gRPC RPC are we using to do that?
So the RPC is called SSH upload back. That's for the fetch case. The other direction is called SSH receive back. So yeah, we have git fetch, and that spawns gitly SSH, and that makes an RPC connection to Gitaly.
Gitaly wherever?
Yeah, Gitaly where exactly. And that spawns git upload back. And of course, here we have gitaly-ruby, which spawns that thing. And we have Gitaly, gRPC on internal Unix socket. With that. Are you dizzy yet?
No, in front of that, then we have the actual GitLab CE.
Yes, exactly. So you have GitLab CE.
Full circle, hooray!
Yes, exactly. GitLab CE makes a gRPC call to Gitaly. And we have this crazy path. And the magic is that this Gitaly, so this is on server 1, so Gitaly 1, and this is Gitaly 2. Yeah.
And by Gitaly 1, you mean the Ruby, and 2, you mean the SSH executable?
No, I mean that these might be different machines at different network addresses.
Whoops, yeah, that's right.
Because in the general case on gitlab.com, the fork might be on a completely different Gitly server. And it's also worth noting that, sorry for that noise, it's worth noting that the way we designed this, even in GDK, where there is no Gitaly 1 and 2, there's only one Gitaly process, as long as the source, you're going across a fork, it already makes a network connection. We intentionally design it like that so that this whole network stuff gets exercised more, because if it's a mechanism that only kicks in when you have two Gitly servers, then you can have bugs that you don't find out about unless you have two Gitly servers. And it already kicks in with one Gitly server. So that thing is then actually making a connection to itself. And that has to be authenticated, so it gets the authentication all the way back from GitLab CE.
It authenticates to itself.
Yes, exactly. Because it's an external connection just coming in again. Yeah, wow. We didn't even talk about merge commits. But yeah, I think we're over 1 hour now, so we should leave it at this for this time. Any last questions? No? Okay, then let's see if I can successfully, without bumbling, turn off the recording. Stop recording. Bye.